Okay, let's move on to rates of return for different holding periods. In this example, we're going to talk about a zero coupon bond. In this case, the par is 100. We've got maturity T, price P, and of course, the total risk-free return is represented by RF with T. So we've got 100 as our zero coupon bond par, and then we have the price times the time, and then -1 because we want to take the 1 off the interest rate, so we actually get a full interest rate. And of course, an example would be helpful here. So let's look at some annualized returns. Suppose zero coupon treasuries with a face value of $100 and various maturities are as follows. We find their total return as this chart shows. The horizon is time T, so we have a half a year, and 25 years. We have the price that is quoted for $97.36, $95, and $23. Now remember, these are zero coupon bonds. If you remember how these work from corporate finance, you know that what you do is you pay the price of $23.30, and 25 years later, you get the face value of $100. So they are discounted. They don't pay you interest along the way. They just simply reduce the price to make up for that difference in interest, and you gain every year or every 6 months. The value goes up. So the price here, a half year, you'd pay $97.36, and then at the end of the half year, you'd get 100 at $95.52, and in a year, you would get 100 and $23.30, and in 25 years, you would get 100. Now, the math on that is 100 divided by PT, in this case, the price times the time, which is given here -1. You can see the -1 here in the equation simply takes the 1 off of the decimal, so we can turn it into percentages. So we always want to use full one numbers because we don't want negatives. You don't want a negative percentage in your interest rates. So anyway, the risk-free rate given the horizon is, we have the risk-free return for a half a year, that's 0.5 here. Half a year is 2.71%, and a year is 4.69, and 25 years is 329%. So if you want 329% on your money, you would buy the 25-year zero coupon treasury. Of course, you have to wait 25 years to get your 329%, or you have to sell at the market at the current market price. So when you see this return is not annual. This return is for the holding period. This is the return over 25 years, not the return per year over 25 years. If we want to look at an annual rate of return, we can use the effective annual rate. The effective annual rate is not a new equation either. It came from corporate finance as well. So we have 1 plus the effective annual rate is 1 plus the risk-free rate times the time, and that's raised to the 1 divided by T power, which is the compounding factor or discounting factor in this case of the investment. So we can find an effective annual rate for that investment, and that is for 1 year horizon. So now instead of a holding period return, we're getting an effective annual rate for each year of the holding period. Now we also can use annual percentage rate, which is simply annualizing by simple interest. As you can see, there's no discounting factor here. We're discounting it by T, which is the time. And so we're discounting one in a compounding way, and the other one we're using simple interest. So when you think of the difference between APR and EAR, APR is based on simple interest, while EAR takes compound interest into account. APR is usually used for mortgages and auto loans and so on, while EAR, which the compounding is more effective for evaluating frequently compounding amounts such as credit cards and so on. We can show a table here, and we have a table here. We've got a year, 6 months, quarter, month, week, day in continuous compounding. That was another example that we should have covered in corporate finance when you learned the time value of money. And in this case, you can see the EAR up here is 0.58, and as you look at the times here, you can see that it's pretty close to 0.58, but not exactly 0.58 in different time periods. And of course, you get the same thing with APR. It's 0.58, but then as you look at it over different time periods, it's a little bit different because there's no compounding. So the APR AR issue takes a holding period and breaks it into an annual rate, whereas the holding period itself is simply the rate over the entire life of the investment. So it's very important that you understand that a holding period is from the beginning of the investment to the end, and an APR or EAR is an annual return on average per year over the investment.